Now my next point is amphoteric nature of water. Now what is meaning by amphoteric nature? Amphoteric nature means the substance behave as acid as well as base, which means the substance work or act as acid as well as base. For example, amphoteric nature of water, which means water behave as acid as well as water behave as a base. For example, look at the two example. I am taking two example. In the first example, water react with ammonia, and in that case, water act as acid. And in the second example, when water react with HCl, here water act as base, which means water behave as acid as well as base. That behavior of water is called amphoteric nature of water. Now in the first case, why water act as acid? Because the opposite reactant such as ammonia, NH3, is a strong base. So nature of water act as acid as well as base depends on the opposite reactant. If opposite reactant is strong base, then water act as acid. And if opposite reactant is strong acid, in that case water act as base. For example, in the first case, water react with ammonia to form OH minus and NH4 plus. Now here water act as acid because opposite reactant NH3 is a strong base. So ammonia is a strong base. And because ammonia is a strong base, water in the first case act as acid. Now water react with NH3 to form OH minus and NH4 plus. Now water act as acid, ammonia act as base. Now tell me, out of two, OH minus and NH4 plus, which is acid and which is base? Out of two, NH4 plus is an acid, while OH minus is a base. Always remember that the positively charged species are called as acid and negatively charged species are called base in case of product. In case of conversion, after conversion, when we got plus and species and negative species, in that case after conversion we can say that plus species is called acid and minus species is called base. So now we will find out the two conjugate acid base pair. In the first case, this is acid base pair, conjugate acid base pair, means H2O and OH minus is the first conjugate acid pair, and which is second, NH3 and NH4 plus, which is conjugate acid base pair. So as we have discussed in the last theory, conjugate acid base pair, here also this example contain two conjugate acid base pair. First, H2O and OH minus is first conjugate acid base pair, and second one NH3 and NH4 plus, which is also second conjugate acid base pair. Now what is the definition of conjugate acid base pair? Conjugate acid base pair are those which differ by only H plus, which differ by only proton. For example, look at the first conjugate acid base pair. For example, water and OH minus is the first conjugate acid base pair. Now what is the difference between water and OH minus? You can see that the difference is only H plus, proton. In the second pair also NH3 and NH4. What is the difference? The differ is only H plus. So conjugate acid base pair are those which differ by only H plus, which differ by proton, because we know that H plus is also called as a proton. Now in the second example, when water react with HCl, water act as base. Now in the second example, why water act as base? Because the opposite reactant HCl is a strong acid. So HCl is a strong acid. So because opposite reactant strong acid, water act as base. Here opposite reactant is strong base, that is why water act as acid. But here opposite reactant acid is a strong acid, that is why water behave as a base. So we can say that, always remember that the nature of water act as acid and base, it depends upon the opposite reactant. Now in the case when water react with HCl to form H3O plus plus Cl minus. Now in case of Amphoteric nature, we are applying Bronsted-Lowry theory. According to Bronsted-Lowry theory, what is acid? Acid is a substance which donate H plus. So here water is an acid, that is why according to Bronsted-Lowry theory, water donate H plus and convert it to OH minus. And NH3 by gaining H plus, according to Bronsted-Lowry theory, it is converted to NH4 plus. Here also HCl is act as acid, and according to the Bronsted-Lowry theory, HCl is acid and acid donate H plus. That is why HCl is converted to Cl minus. And H2 is a base in this case. And what is the definition of base according to Bronsted-Lowry theory? Base is a substance which accept proton, which accept H plus. So base H2 accept H plus from HCl, converted to H3O plus. Now this is the product side when H2 react with HCl to form H3O plus plus Cl minus. Now tell me, out of these two, Cl minus H3O plus, which is acid and which is base? I have already told that the plus species means positively charged species. As I told earlier, the positively charged species are called as acid, and negatively charged species are called base. So H3O plus. So because it carries plus charge, H3O plus is an acid. As I told earlier, the Cl minus is called as base. So always remember the positively charged. In case of product side, after conversion, the positively charged species is called acid, like NH4 plus is acid, and negatively charged is called base, as like OH minus is called base. Now we will find out, as like in the first case, two conjugate acid base pair. So in the first case, HCl and Cl minus. HCl and Cl minus is our first conjugate acid base pair. Which is second one? H2O and H3O plus. H2O and H3O plus, which is our second conjugate acid base pair. So likewise here, first reaction contain two conjugate acid base pair, and here also second example contain two conjugate acid base pair. Now again, definition of conjugate acid base pair. Conjugate acid base pair are those which differ by only H plus. So look at the first conjugate acid pair, HCl and Cl minus. You will find that the differ between HCl and Cl minus is H plus. Also look at the second conjugate acid base pair, H2O and H3O plus. What is the difference between H2O and H3O plus? They differ by only H plus or proton. H plus or proton. So this is so that was the regarding the amphoteric nature of water. What is the definition of amphoteric nature of water? The water has the ability to act as